Hello, I'm Dr. Jackie Borman from Purdue University, and on behalf of the entire Virtual Dairy Nutrition and Management Series Planning Committee, we want to thank the graduate students who are presenting on dairy sustainability. We appreciate the time and the information that they will be sharing with us today. And for those of you that are listening, thank you for your attention in this important area of dairy sustainability. Our first presenter is Andrew Richards. Andrew is a master's student from Purdue University who will be sharing his research about utilizing data generated on farm to reduce feed waste.
It is well known that in order for the modern dairy farm to survive and be profitable, it also has to be sustainable. Sustainability can be simply put as the balance between economic, social, and environmental factors. A part of being sustainable on the farm is the efficient use of resources such as feed. Many farms strive to utilize their feed properly, but still come up short, resulting in feed waste, also known as feed refusals. Feed refusals are just the leftover uneaten feed from the previous day. Feed refusals happen because cows do not consume the same amount of feed every day due to a variety of factors such as milk yield, health status, social interactions, weather, and feed composition, just to list a few. The optimal range to shoot for is around 2 to 4% feed refusals. We never want 0% because we need to ad libitum feed for ideal milk production for the cows, so make sure they always have access to feed. But why are feed refusals a problem? Well, for starters, feed cost represents the single largest cost on dairy farms, accounting for around 50% of the total cost of producing milk. When you underfeed cattle, so refusal rates below 2%, you lose milk production, and it can have negative effects on your cattle's health. When cows are overfed, so greater than 4% feed refusals, you increase your feed waste and also your feed costs. And it is estimated that increasing the amount of dry matter refused by 1% can cost upwards of $20 per cow per year. Plus, when you overfeed, you also have excessive excretion of nutrients into the environment. So it has a negative effect on sustainability, your costs, and also cow health. So to try and figure out solutions, we asked the question, are there quantifiable factors that are already measured on farm that impact pen level intake? And if they are they repeatable across pens and across farms? If there is, can we use them to predict pen level intake in real time for the farm, ultimately reducing feed waste and maximizing marginal milk production? So to try and answer our questions, we started looking at the different data streams on the farm. We had a weather station on the farm, which was useful because we got on-farm temperature straight from it. We also utilized AffyMilk, a milking parlor management software, which was good for getting number of cows in a pen and milk yield. We also utilized EasyFeed, a feed management software, which we used to pull feed data from. And we also looked at DairyComp 305, a farm management software. So from these on-farm data sources up here in the circle, we pulled data from them, and we took that data and analyzed it in RStudio, which is a statistical program. In RStudio, the data was merged together and analyzed. We merged it by date and pen, as you can see in this Excel sheet. This is what it would look like. From this analysis, we found variables that significantly affect dry matter intake. So far, our results have shown that dry matter percent of the diet, number of cows in the pen, the quadratic effect of milk yield, the interaction between milk yield and the number of cows, and lastly, temperature, all significantly affected dry matter intake. And on the side, there are some line graphs. The top shows temperature's effect on dry matter intake. And you can see as temperature went up, dry matter intake decreased. And in the middle shows yield per cow, and as yield per cow went up, dry matter intake also went up. And lastly, on the bottom, we have number of cows. As number of cows in the pen increased, dry matter intake also decreased. This means that this pen is either overstaffed or is not a good pen to add more cows to. These are all taken on a single pen. Ultimately, our goal will be to be able to collect data on significant variables for the current day and be able to analyze them using a predictive equation that will automatically generate feed changes that need to be made. So the farm can then adjust their second feeding to be more accurate, to more accurately deliver what the cows will need in that day. So again, ideally, we want to collect, analyze, and adjust. Other factors to keep in mind that affect dry matter intake is cow behavior and management. How a cow will behave and eat is affected by factors like housing and how they are kept. Are they in pens, groups? Are they outside? These kind of things have an effect on intake. Other considerations is weather, cold or hot. Temperature has been known as seen. Particle size is also an important factor. Unchopped feed will result in sorting behavior of cattle. Another is feed drops and push-ups. Both feed drop and push-up have been found to promote intake. Overstocking is also a well-known factor that decreases dry matter intake, resulting in more refusals. So some management strategies that can be used to avoid more feed refusals and undesirable cow behavior are to group animals that are similar. For example, you want to group animals that may have similar milk production levels, so they are producing similar amounts, so their feed requirements will be similar. Thus, you can estimate that their intakes will be similar as well and not be diverse amongst the pen. This compared to a diverse pen with a lot of different animals in different lactations maybe, you'll have a larger range of intakes, making daily pen feed making it harder to predict how much feed that diverse pen will need. Other strategies to keep in mind are regulate barn temperatures and stocking density. Another useful tool is to feed twice a day. That way you can make adjustments in the second feeding if need be. And also to just push up feed. It's simple and easy and it works. Lastly is the matter of shrink and what to do with feed waste. Ideally, you just want to get rid of that feed waste, but if it is still somewhat usable, give it to beef animals or steers. Do not give it to any other animals on the farm. Other considerations is to reduce shrink is to manage feed and silage bumps as well. This is all good, but how can some of these results help you? You can most likely expect similar trends on your own farm. So if there is a pen that is increasing in milk yield, you can expect to feed more to that pen. And if you see that it is a hot day out, you can expect to see feed intake decrease. Same goes for if you have a lot of animals in a pen to the point of overcrowding, you can expect intakes to be lower. And if you add a lot of cows to a pen on a hot day, you expect average intake to decrease as well. So it will most likely follow similar trends to these graphs as well. Going forward, our next steps will be to continue to analyze more variables from data sources on the farm and build upon the variables that significantly affect dry matter intake. We also want to find variables that account for cows' behavior on dry matter intake, as well as analyze more on a pen level basis than just the whole farm. Doing this would allow us to determine more pen-specific variables that are affecting intake. Some variables also might affect a specific pen more than others. So for example, if the fans are out in a certain pen, temperature might affect them more on a hot day than, say, a pen that has working fans. And lastly, we are going to continue to collect data on the farm. And I would just like to thank and acknowledge IOTA and Vet and Dairy Group for their contributions, and thank you.